All right, so we're recording right now, so let's jump back in. We got part C here, right? To number 2. If f double prime of 200 is negative 0.1, explain in a full sentence. Okay, so to get the units here, let's go ahead and do this. Let's create an f prime of t graph, okay, against time. F prime of t, we said way over here, which I guess we can call it C prime of Q, really. My bad, I forgot what problem we're working here. We're working the ice cream problem, so quarts, there we go, Q. So the first derivative was dollars per quart. So now, if we graph the derivative, we have dollars per quart on the y-axis against quarts on the x-axis. And therefore, the derivative of the first derivative, which we call the second derivative, okay, it's not f prime of t. I'll just get rid of that altogether. It'd be c double prime of q. Or in Leibniz notation, remember, this would be the second derivative of c with respect to q squared. Anytime you take a derivative of something, anytime, it's always going to be units of y divided by units of x. So again, that's going to be dollars per quart, or dollars per quart squared. That's the acceleration of the cost, if you want to think about it that way. So let's go ahead and write our sentence. What are the units of 200 here? Quarts, right? So we'll just say when t, I keep using t, why? When q equals 200 quarts. If you don't put units on your sentence, you're going to lose the check that you usually would otherwise get for writing the sentence. So don't just say it q equals 200. Okay? In sentences, you need the units for the input and the output. There's your moment in time, right? That captures the instantaneous part. Now, the second derivative measures the rate of change in the first derivative. So I need to see what that quantity is. What would you call the quantity C prime? C is the cost, right? The production cost. So what would C prime be? Do we have a term for that? No. Can we just call it the change in production cost or the change in cost? We know it's production cost, right? So again, when we talk about motion, the second derivative is going to be acceleration, and we have a real intuitive understanding of what that is. But when we're not talking about motion, the second derivative can be kind of like, huh? But it's the change in cost. So when Q equals 200 quarts, we'll just say the change in cost, in production cost, if you want to write that out, the change in cost is whating? Increasing or decreasing? Decreasing, right? So we have a negative numeric answer, which is great. But in our sentence, we interpret that as a vector. So if you ever have a negative rate, you're going to say decreasing. And then you're going to say by, and now you drop the negative. We've already interpreted the negative, so now we look at the magnitude, which is 0.1. And we're going to say by 0.1, and we're going to talk about units of C prime, which are dollars per quart, all right? Are decreasing by 0.1, I'm going to write this out here, dollars per quart, right? Because that's the units of C prime, or the units in change in cost. Let me highlight that in a different color. The change in cost, and these have to match, okay? And then we'll say per quart. That's the one we spell out. Here's an easy way to remember it. At the end of your sentence, every sentence that's a rate equation should always have something spelled out at the end. Per quart, every hour, whatever. And then everything else that you haven't said gets lumped into the units there, all right? So when, or at the 200 quart production level, the change in cost is decreasing by $0.1 per quart for each and every quart. $0.1 per quart, we could probably change the units there if we wanted to get bold, right? What is $0.1? 10 cents. So if you wanted to modify it, you could say that the change in cost is decreasing by 10 cents per quart for every quart, all right? So basically, here's what we could say. Production costs are increasing at a decreasing rate. It's curved down. Is that good if you're producing ice cream to have a negative second derivative? Here's cost. We know that the cost is a positive number, so it's increasing, but the second derivative is negative, which means the slopes are getting smaller. See that? They're getting flatter. That's not bad for, I mean, costs have to increase, I would guess, right? You can't produce something for nothing. But if they're increasing at a decreasing rate, that's good, right? Because as you produce more and more, it's costing you less and less per unit. Yeah, so that's where the economies of scale kind of kicks in, right? And there's even a time really where that curve could turn on itself and come back down. Diminishing marginal utility. I know you've studied returns, but diminishing marginal utility is a real thing. Being overly prepared, right? Yeah, I stayed up all night in college once to study for a math final. I'd never pulled an all-nighter. And I had recently acquired the taste for coffee. So I'm like, that'd be a good idea. I know this, it's linear algebra. I have 100 in the class. It's a super easy, you know, and it was summer was on the horizon. It was like my last one. I'm like, that's going to be euphoria, baby. I was at A&M my sophomore year. And yeah, there you go. They had played a football game over the weekend, I heard. But anyway, I stayed up all night and I was like drinking coffee, like, hey, I got this. I went to like McDonald's like at 3 a.m. Yeah, give me some breakfast, you know. And I'm like, and I'm just hanging out drinking coffee. And then I went into my test and I looked at it, my brain like short circuited. I was like, you know, fidgety from all the coffee, you know, and I couldn't concentrate. I was wired. And I didn't do so well on the final. I knew the material, but I couldn't perform. Diminishing marginal utility. Too much or a little bit more is not always better, right? There is such thing as too much of a good thing. I passed the class with like a 98. So anyway, that's the end of the final brought me down 2 points on my average though, right? That was bad. Still ain't. But I learned my lesson. I don't go to McDonald's before 4 a.m. anymore. Hey, McDonald's, by the way, I'll give them a shout out for the World. They're giving free breakfast all this week to educators. That's kind of nice. You just have to show them your ID. All right. Any questions on that? I don't know. You have to show them a badge, right? It could be handmade, I guess. Let's look at example 3. I told you it was going to rain. Here it is. Let F of t be the amount of rain in inches that has fallen since midnight. So midnight is going to correspond then with t equals 0. T is the time in hours since midnight. So we have hours and inches, right? In a complete sentence, including units, interpret the following in the context of a problem. What I would recommend you do in every situation where you have to interpret the meaning of a mathematical equation, go ahead and draw yourself a little X and Y axis, okay? And it's usually a first quadrant thing. So F of t against t. We have inches against hours after midnight, right? And now on the inset here, let's do F prime of t. What are the units of F prime of t? Inches per hour. Yeah, you don't have to say divided by anymore. It's always going to be division. Always y divided by x. Always. dy dx, right? Divide. Sweet. All right. So both f and f prime have the same input, though, don't they? It's the same t. It's hours. All right. Let's go to f of 10 equals 3.1. What does 10 represent? Hours after midnight, right? So you could say at t equals 10 hours. Would that suffice? Absolutely. That's answering it like an engineering robot, right? It's meeting all the essentials. You start with your introductory adverbial clause. You state the number, the variable, and the units, and you're done. Is there another way to say that? Yeah, 10 hours after midnight or at 10 a.m. Yeah, you need to make sure you say 10 a.m. or at 1000, right? Yeah. Comma, what is the units of 3.1? Inches, right? So at t equals 10 hours, 3.1 inches of rain has fallen. There you go. So do we have two numbers in our sentence? Yes. Do we have two sets of units in our sentence? That's what you want to make sure you check. The number one thing that students leave off in their sentences is this one right here, the hours, the units on the independent variable, because we're not used to writing it. We're used to like showing f of 10 equals 3.1. And if it's your final answer, you would put inches on the back of the dependent variable. Very rarely do we squeeze the word inches inside the parentheses there. So it's real easy to leave it off. But in your sentences, you can't forget to remember. You have to remember to remember. All right. What a children's book this one's going to be. Because look at this. Whoa! You turn that page and it's now like a pop-up book. It's like, whoa, where did that come from? Whoa, it's like raining from underneath, Forrest. I don't know. Yeah. We got all kinds of rain. What is that? F to the negative first. How do we read that? The inverse. It's the inverse, right? That's the notation for the inverse. Remember, an inverse function undoes the work of a function. How do we find the equation of an inverse? What do we do with x and y? Switch them, right? And then resolve. So let's go ahead and do that. We'll do that with the axes as well. Here is the f inverse. Now, on the y-axis, we have what used to be on the x-axis, which was hours. So now we have hours measured on the y-axis, and what used to be on the y-axis in inches is now over here. Now, this is a strange way to think about things, right? Because now we're saying let inches be the independent variable, not time, right? That's weird, but whatever. Now, let's think about the units of the derivative. There's two ways to write it, of course. F inverse, if you take the derivative, we do it like that. We put F inverse in parentheses. If we don't put it in parentheses, then if I put F inverse prime, it looks like F to the negative 11th. Which would be 1 over f to the positive 11th. We reserve this notation for inverse. This does not mean 1 over f, okay? But if that were f squared, it would mean the quantity squared. It's confusing, right? So you could do f inverse prime, or you could say the derivative of f inverse with respect to what? It's still f inverse of t. But this is really weird because t is no longer time, it's inches. We still use the same letter. So it's backwards, okay? But what are the units going to be? That's the more important thing. Hours per inch, got it? All right, let's answer this question now. F inverse of 10, what does 10 represent? Inches, okay? So how about when t equals 10 inches? I have to use t, right? F inverse of t, f of t. When t equals 10 inches. Could you also say when 10 inches of rain have fallen? Yeah, you can. That's more words. But when t equals 10 inches, I better spell it out. You can abbreviate inches in the sentence. I am. Comma, what does 16 represent? Yeah, 16 hours have what? Passed? This passed, right? P-A-S-S-E-D, past tense. Or elapsed, if you want to say that. Gone by, that works, right? Now, that's kind of weird if you think about it that way. When 10 inches of rain has fallen, 16 hours has passed. Because that's the guy who's watching the rainstorm in his window, but instead of looking at his watch saying, huh, it's been 16 hours, I think I'll go check the rain gauge, right? What is he doing? He's watching the rain gauge, right? And he's like, oh, I got to 10. And then he goes and looks at the clock, right? Oh, it's been 16 hours. I really need to get a life. Right? Watching this rain gauge for 16 hours. No wonder I'm hungry. Go ahead and do C and D on your own. I'll see what you get. Don't forget to remind me to restart the video, please. Thank you. Zoom recording. Okay. All right. Let's see how you did with Patty Griffin and Harry Styles here. F prime of 8. So 8, we're going back to F. So in this case, 8 now represents hours again. So again, you can say at 8 a.m. Don't just say at 8 o'clock, right? Because then it's like, what are you talking about? AM, PM, or ZM? Come on. So at T equals 8 hours. Boom. Good. 0.4 measures what we're measuring F. What is F measuring? the amount of rain that has fallen. Okay. Can we call that rainfall? Is that kind of a, can we use rainfall? I would think so. The amount of rain that has fallen, can we call that rainfall? Sure. At t equals 8 hours, rainfall, which is one word, is whating? Increasing. Okay, increasing by 0.4, and now it's going to be derivative units, which are inches per hour. And you could do it with a slash, inches per hour, and then per or each hour. All right, that makes sense, right? At 8 in the morning, the rainfall is increasing by, almost a half an inch per hour each and every hour. It's picking up, right? Like the drum line. Do y'all still play Stigmata by Ministry? Because that's, I skateboarded with Ministry. I killed a few cats listening to Ministry back in the day. No, I didn't. I'm kidding. I didn't kill cats, but some people think Jorgensen in Ministry, they're like into torture and kind of weird satanic ritual stuff. But Stigmata is a good song. Oh, that's what y'all thought. No, hey, remember, I have drain damage this year. Not enough oxygen. At t equals 8 hour, rainfall is increasing by, okay, let me stick to my own accounting or reconciling rule. What are we measuring rainfall in? Inch, collection of rain, the amount of rain. Maybe we shouldn't say rainfall. I think that's what threw me off. How about at t equals 8 hours, the amount of rain. Oh, good. Look, I can just move this over. Hey, that's neat. That has, crap, got to do it again. That has, I feel like TechStop now. You build a road, finish it, and then tear it up, make it wider. And then you do it again indefinitely. The amount of rain that has fallen. There we go. Boom. Now, look, what are we measuring? What do we measure the amount of rain that has fallen in? What units? Yes, by 0.4 inches. That's what has to align. And then per hour. Thank you. I was into the second derivative there. I wanted to get another drumline joke, so that's when I was thinking it's picking up, but that's second derivative. Having a positive first derivative just means it's raining, right? Because we're collecting rain. All right, now this one's wacky. Let's see how y'all did on this one. What is the input on 5? By the way, I will intentionally and most often unintentionally make mistakes all year long, right? Your job is to catch them. Don't be timid. Don't be shy. I'm not easily offended. Okay. But if I am, you don't want to see that. So, oh, yeah. No, I'm kidding. Point it out always. Mistakes are part of the process, right? Mistakes are part of the learning process. All right. What are the units on 5? 5 inches. Okay. So how about at t equals 5 inches, which let's go ahead and try and dabble into the English arts here a little bit. When 5 inches have fallen, that's what that would be, right? Comma. This is the rate of change of F inverse. What are we measuring on the y-axis on F inverse? What do we measure in hours here? Hours after midnight? Or time? Time. We're measuring time. Time. Right? At t equals 5 inches, time is whating. How do we know it's increasing? Don't say because that's how time works, because that would be a great answer. But it's because it's positive. It's a good thing that's a positive number, because if that were not a positive number, we'd be like Harvard, Harvard, Harvard. That's why none of y'all want to go to Harvard if that were negative, right? Time is passing, since y'all used past last time, or elapsing at 2. What are the units of F inverse? At 2. Hours per inch. What are we measuring? No, see, now you're doing what I did last time. Now you're doing what I'm doing last time. We're talking about F inverse. So it's hours at 2 hours per inch. There we go. Right? You always go back to this right here. That's what's changing. And you spell out hours per inch. So that would be that guy that was watching the rain gauge from the window. Now, and Landon knows this, now he's evolved. Now he's walking around not with a wristwatch, but with a rain gauge on his wrist. And he's like, doo, 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 right? Oh, look, blah, blah, inches have fallen. It must be whatever o'clock, right? Yeah, now o'clock, right? Oh, look, my rain gauge got up to 5, so time is now passing at 2 hours every inch. What a world that would be, right? Okay, we got through the sentences. Tomorrow we'll start with Richard Nixon. Yeah. He was a Quaker. He went to Whittier College, which they are Whittier than the people at Harvard. Y'all have a fantastic rest of the day. Stay mathy, and treat people with kindness.